All right, we're working on the Unit 8 review, graphing sine, cosine, and tangent. Identify the amplitude and period. So the amplitude is going to be, the absolute value of -2, which is just 2. And the period for sine and cosine is 2 pi divided by the number b for x, which in this case is just 1, so it's 2 pi. Here the amplitude is going to be the absolute value of 3, which is just 3, and then 2 pi divided by 2, which simplifies to pi. This one, the amplitude is the absolute value of 1/2, and then 2 pi divided by 4, which is going to be pi over 2, and we reduce. And then this one, absolute value of -3/4, which is +3/4. And then for this one, when we do 2 pi, it's going to be 1/2. And then we're going to copy dot flip that to see that our period is 4 pi. Okay, this one says identify the period and reference point and asymptotes if applicable. So I just want you guys to see, we're going to change this to transformations. So period is going to be, remember for tangent, it's only pi divided by b. So pi divided by pi over 4. So let me show you guys the math for that real quick, because we haven't done much where the number in front of the x actually has a pi in it. So if you do pi divided by pi over 4, only one fraction bar, so we have to do copy dot flip. And then what you notice is the pi's cancel out, so this period is just 4. And then the only transformation that we have here is reflect over x-axis. And then the asymptotes, we're going to set them equal to, so we have pi over 4 x equals -pi over 2, and then pi over 4x equals +pi over 2. So this just becomes another copy dot flip problem, because to get the x by itself, I have to divide by pi over 4. And then I'm going to keep change flip that. And then the pi's cancel out again, and I get -4 over 2, which is going to be -2. And then over here, I'm going to get the same thing, but I am going to get +2. So watch out for those, because those do show up on the test. If there is a pi over 4 or any pi before x, it's going to cancel with the number in the period. The period does not have to have a pi in it, neither do the asymptotes, okay? We don't usually ask you to graph those, because the graphs that we provide you, the x-axis is usually labeled with values that are angle values, but just know that the math still works out the same way. Okay, for this one, the period is going to be pi divided by the number before x, which is just 1. So this one's just pi. We are going to see that this is going to go right pi over 2 because of whatever's in the parentheses, and then it's going to go down 1. However, we don't really have to know the horizontal transformation, because when we set up the equation for the asymptotes, it's taken care of. So x minus pi over 2 equals -pi over 2, and x minus pi over 2 equals +pi over 2. And then I'm going to add pi over 2 to both sides, and then I'm going to get x equals a -pi over 2 and a +pi over 2 just gives me 0. And then when I do that to the other side, or the other equation, again, a good tip is to go ahead and pretend like it says 1/2 plus 1/2 rather than pi over 2 plus pi over 2. So that equals pi. Okay, for C, The period is going to be pi divided by the number before x, so that's pi over 2. For transformations, I see up 1/2. And I do have a horizontal transformation, but because we're going to take care of it with the asymptotes, I'm just not going to really do the math for it. We don't need it to graph it. But to find the asymptotes, it's 2x minus pi over 3 equals negative pi over 2. So the first thing we're going to do is add pi over 3 to both sides. So that gives us 2x equals, and then I have to do some math here. This gets multiplied by 2, and this gets multiplied by 3, so I have common denominators. So that's going to be negative 3 pi over 6 plus 2 pi over 6. And then when I do negative 3 and positive 2, that just equals negative 1. So negative 1 pi over 6. And then I'm going to multiply both sides by 1/2 instead of dividing by 2, just because it makes the fraction math easier. So that gives me x equals negative pi over 12. And then for the other asymptote, same thing, except for we are going to set that equal to positive pi over 2. So I'm going to add pi over 3 to the other side. So I get 2x equals pi over 2 plus pi over 3. Get those common denominators again. This one needs a 3. So I get 2x equals 3 pi over 6 plus 4 plus 2 pi over 6. So I get 2x equals 5 pi over 6. And then if you wanted to divide by 2 instead of multiply by 1/2, just make sure it's 2 over 1. So that when you copy dot flip, you get 1/2. So then you get x equals 5 pi over 12. And that's it for that one. We are identifying the transformations, not reference points. Again, we're going to do transformations. Okay, so with these, the way that you do the transformations is whatever is in parentheses, you set it equal to 0, and then get the x by itself. So we're going to have x equals pi over 2. So that's just going to be right pi over 2. And there's no vertical transformation, so that's all we have to write for that one. So for this one, I can right away see up 7. So I'm going to write up 7 so I don't forget that. And then this one, x plus pi over 6 equals 0, and then we would subtract it. Some of you can do that math in your head, that's fine. The tricky part is when there's a number in front of the x, that's when it's hard to do it in your head. So that's left pi over 6. This one right here, there's nothing in with the x, so if I set that, I just get x equals 0, which means there is no horizontal transformation, but there is a vertical transformation of down 2. This one, we have a reflect over the x-axis. And then we also have an up 3. And then we set this part equal to 0 and subtract. So that's going to be left 2 pi. E, we are going to do down 1/4. And then we just need to set this whole thing equal to 0 and solve for x. So I'm going to move the pi over 4 to the other side. So that gives me 1/2 x equals positive pi over 4. Then I'm going to multiply both sides by 2. So then I get x equals, I can reduce this 2 and that 4. 2 goes into 2 once and 2 goes into 4 2 times. So that leaves me with just x equals pi over 2, which means this is going to go right pi over 2. Okay, now we're actually going to get into some graphing. You guys have the same thing on your test tomorrow. The only difference is this piece down here will actually say transformations. So amplitude is the number in front of the function, which is a 1. The period is going to be 2 pi divided by 2, which is pi. And since we're not going up or down at all, the midline's going to stay at 0, and there is no transformation here. So the key with these sine and cosine graphs is to go to the pi, which is like right here. And we need to cut that into 4 equal parts. So from 0 to pi, halfway is here, and then a quarter of the way and 3/4 of the way. I don't really like using the dots because then they look like points. So we know sine starts at 0 and then goes up. So this is just gonna follow our 5-point pattern, which for sine starts at 0. So there's that graph right there. Okay, moving on to the next one. This one, you are going to do the amplitude is 2 this time. So that's the distance from the midline. The period is 2 pi divided by 2, which is going to be pi. And again, because we didn't go up or down at all, this is y equals 0. And as far as the transformations go, there are none in here. So just like on the last problem, we're going to go to pi and then cut it in half, which happens to be at pi over 2. Now cut from 0 to pi over 2 in half, and from pi over 2 to pi in half, and you will be there. Those are your hash marks, so you know where to plot your graph. Cosine starts up at its amplitude, so because it's a positive amplitude, because it's a positive a value and there's no reflection, we're just going to start right there. Okay, and now on to the back side. For C, we do have a couple of new things. So the amplitude is going to be 3. For our transformations, I see 2 obvious ones. First, we're going to reflect over the x-axis. And we need to go up 1. And then for the period, it's going to be 2 pi divided by 4, which is pi over 2. And because I'm going up 1, it's going to shift the whole graph up 1, including the middle of the graph or the midline. So it's going to be y equals 1. Just in case you haven't picked up this pattern, if there's a vertical transformation, that's what's changing your midline. Okay, so my period is pi over 2, which is right here. So from 0 to pi over 2, that's in half. And then I need to cut those halves in half again to be able to get this graph. And then before I graph my actual graph, I'm going to graph it before I move it up 1. So -3 sine, it's going to start here at 0, but then it's going to come down to -3, then go back to 0. And the reason why it's going down is because of that reflection. And then it's going to go up to 3 and then come back to 0. And then I have to move everything up 1. So up 1, up 1, up 1, up 1, and up 1. So it'll look like that. Okay, next one. Amplitude is going to be 1. I see a down 2, which means my midline is going to be -2. And then I also see reflect over x-axis. So it really matters your starting point. And for cosine, it's going to start at the amplitude. This is 2 pi divided by the number before x, which is just a 1, so this is 2 pi. Okay, so I go to 2 pi, cut it in half, and then cut it in half, each of those halves in half. And then I'm doing negative cosine, so it's going to start at -1. And then you're skipping 2 boxes now because of where the period is and how this graph is stretched more than the ones we've been graphing. And then I need to move everything down too. So that one looks like that. Okay, moving on to E, amplitude, absolute value of the number before the function. So that's 1. Period is going to be 2 pi divided by the number before x. So it's 2 pi. The midline is going to be y equals 3 because it's going up 3. So, and there's no reflection, but there is a horizontal. So the way we find the horizontal transformation is by setting whatever's in the parentheses equal to 0 and solving for x. So it's going to be left pi over 2. So when I go to 2 pi and I make my marks, I notice that pi over 2 is 2 squares. So when I have to move it left 2, each point is going to be moved left 2 squares. Okay, so normal graph, we start at 0 because it's sine. And then we go up back to 0, down to the negative amplitude, back to 0. And then I'm going to move it left 2 squares and up 3 squares. So left 2 squares, up 3 squares, left 2 squares. And if you have that midline on there, once you find it, like it's almost easier to graph rather than shifting each point. That's a really wobbly graph. Okay, last one on this page. So the amplitude is going to be 4. Period is 2 pi divided by the number before x, which is just 2 pi. I don't have any vertical shifts, so it's just going to be y equals 0. And then to find my horizontal, when it's sine or cosine, I set it equal to 0. So I get x equals pi, which means this is going right pi. So go to your period, which is 2 pi. From 0 to 2 pi, we got 4 equal marks, so we can draw our pattern for cosine. We're going to go and notice that pi is 4 squares. So when we go right pi, we're going to go right 4 squares. So when I draw the basic graph before I shift, I'm going to start at 4 and do the pattern for cosine. But then I'm going to move everything right 4 squares. Midline is still 0. And then connect. Alrighty. Okay, now we're moving on to some of these tangent graphs. And tangent, other than vertical transformations, you don't have to worry. Tangent, when you do the asymptotes, you get a bonus because it automatically does the period for you, and it shifts your graphs, and it gives you the asymptote, so I guess it's a 3-for-1. So for this tangent right here, the pseudo amplitude is going to be 2. The period is pi divided by 1/2. And so we have to copy dot flip that. So again, remember tangent, it's a faster graph, meaning it only takes pi to go through 1 rotation instead of 2 pi. Except for on this one, when we have that 1/2 in front of the x, it is 2 pi. We are not doing a reference point and there are no transformations. So now we just have to set up the asymptote work. So whatever's in with the parentheses is we're going to set equal to negative pi over 2 and a 2 pi. And solve. So that's going to be x equals negative pi, and then times 2, and x equals pi. Woo. So we go to our graph and we draw those asymptotes where we calculated them to be, and then midway between is the x-intercept, and then 1/4 of the way, so that's right here at negative pi over 2, we're going to do the negative amplitude, and 3/4 of the way, or the third hash mark, we're going to do the positive amplitude or pseudo amplitude, and then we're going to draw it. Make sure you put arrows because that does go on forever. Okay, this one right here, the period is pi divided by 1, so that's just pi. We do have some transformations. We do have right pi over 4, but we don't need to worry about that when we graph because the asymptotes will take care of it, and we have down 2. So the only one we have to worry about with tangent is the down 2. To find our asymptotes, we are going to do this math right here, and we're going to do this math. And again, this is the fraction math that most students end up having trouble with, so just take your time, get common denominators. So I have to add pi over 4, and in order to do that, I have to multiply this by 2. So I get x equals negative 2 pi over 4 plus 1 pi over 4. And negative 2 and positive 1 is negative 1/4. So negative pi over 4. And then I'm going to do the same thing over here. And then again, getting common denominators. And so this one's going to be 2 pi plus another pi is going to be 3 pi over 4. And if you notice, the distance from negative pi over 4 to 3 pi over 4 is consistent with your period. So we don't really have to use the period to find our marks. We use the asymptotes, but it is there to double check to make sure you found your asymptotes properly. Okay, our pseudo amplitude is 1 here, and so the points that we would graph are here and here and here, but we have to move everything down 2. And there's our graph for that tangent. Okay, for this graph right here, letter C, first thing I notice is that I do have a reflection over x-axis. I also see that I'm going to go up 1, and I am going to go left pi, but when we graph, the asymptote work will take care of that, so I don't have to worry about that. The period is going to be pi divided by the number before x, which is just pi. So for the asymptotes, I have x plus pi equals negative pi over 2. That's our first one. So I'm going to subtract pi from both sides. And then because these aren't common denominators, I'm going to put that over 1. So I end up with x equals negative pi over 2 minus 2 pi over 2. And if I have a negative 1 and a negative 2, that makes negative 3. So the first asymptote is at negative 3 pi over 2. And then for the other one, it's going to be x plus pi equals positive pi over 2. Doing that same fraction work, that's going to give me that x equals negative pi over 2. So I'm going to go to negative pi over 2, which is here, and go to negative 3 pi over 2, which is here, and then I'm going to because it's a negative 3, it's going to reflect. So the amplitude, the positive one is going to be the first one this time, and the negative one is going to be 3/4 of the way, and then from there I just move every point up 1. Okay, last one here. The period is going to be pi divided by 2. There is no horizontal transformation, but I am going to go up 5 over 2, and then my asymptotes are 2x equals negative pi over 2. Do the math for that by multiplying both sides by 1/2, and then you get x equals negative pi over 4, and then 2x equals pi over 2. And again, you can divide by 2 if you want, but just remember to make this 2 over 1 so that when you copy dot flip, you get the right answer, okay? And so that would mean that x equals negative pi over 4 and positive pi over 4. So that's here and here. And then I have to make 4 marks. I gotta get all my little marks in there. I have to get 4 spaces, I should say. And then the amplitude is 1/2. So before I move everything up, I am going to be negative 1/2, and then 0, and then 1/2. And then I have to move everything up 2.5. So that's gonna be here. And then if I go up 2.5 on that, it's there, and 2.5 up on that, it's there. And that's that graph right there.